What do you think would make two matrices, not determinants, two matrices equal? How do you think we would know if two matrices were equal? David? Good. First and foremost, you need the same number of same rows and columns, right? So basically they have to have the same what? If they have to have the same rows and columns, what is that? It's dimensions. So for two matrices to be the same, they have to have the same dimensions. And in addition to that, not only do they have to have the same dimensions, they have to have the same number in the same element position. So it can't just be that, like, you know, the first matrix has an element of 1 in the top left, and then has an element in the second one has an element of 1 in the bottom right, and then we say they're the same because they both have a 1 in there. They both have to have the same in the same positioning. So I want us to determine if the matrices are equal. So I have -2, 1, 6, and I have a 3, -1, 2. And then I'll have a -6/3, 7/7, -12 over -2. And then the row beneath that, we're going to have 12/4, -8/8, 4/2. All right, so the first thing I'm going to check is the dimensions of each matrix. Remember, dimensions are rows by columns, right? So how many rows do I have here? 2. So we're 2. How many columns do we have? 3. So I'm a 2 by 3, and in the second one, is it also a 2 by 3? All right, so the dimensions match up. Now we need to double check these elements. So obviously the first one, there's nothing I could do with the elements, but the second one, can I simplify down those fractions? So -6/3 reduces down to -2. 7/7 reduces down to 1. -12 over -2, 6. Then for the second row, 12/4 is 3. -8/8 is -1. 4/2 is 2. Do the corresponding elements match up? Are they the same? Corresponding elements are equal. They're the same dimensions. Are these two matrices equal? Yes. Are these matrices equal? No, it's not. It depends. It's a yes or no. All right, I'm going to go with no also. All right, why no? How come I said no? It doesn't depend. This is a no. This is a solid, firm no is a sentence no. Matt. You got it. So remember, the first thing I said about matrices, for them to be equivalent to each other, they have to have the same dimensions. So the first one is 1 by 3, and the second one is a 3 by 1. That's not the same. Do they have the same numbers in them? Yeah, but that doesn't mean anything if their dimensions aren't the same. So no. Different dimensions. All right, let's talk about matrix addition. All right, any two matrices can be added. Claudia, can we turn around? Thank you. Any two matrices can be added if they have the same dimensions. So matrices can be added as long as they have the same dimensions. So if I tell you matrix A is has the elements -3, -2, 5, 6, and then B, we have 4, 8, -7, -3. Do these matrices have the same dimensions? Yes, so therefore I can add them. That's really the only criteria you need in order to add two matrices together. So then if I ask you what's A plus B, so this is saying what's matrix A plus matrix B, all you're going to do is add the elements that are in the same position. So I'm going to add -3 with 4 because they're both top left. And then I'm going to add -2 with 8. Now let's go down to the bottom. I'm going to add 5 with -7. And last but not least, I'm going to add 6 with -3. So we end up with 1, 6, -2, 3. And that is A plus B. All right, let's say I told you matrix A is represented by -3, -2, 5, 6, and matrix C is 1 column, 4, -7, 1. And I ask you to find A plus C. Can we add these? No, why not? They're not the same dimension. So if I asked you to write two things that are that do not have the same dimensions, you would say A plus C is not defined, meaning we can't add them. All right, let's think back to the basic rules of arithmetic. What is the additive identity? Well, first, what is an identity? It is a property that does what? It gives you back whatever you started with. An identity gives you back whatever you started with. So what number is the additive identity? What number, no matter what you add to it, gives you back what you started with? 0. So the additive identity is 0, right? A plus 0 is A. All right, let's talk about the additive identity matrix. What do you think the additive identity matrix is going to be?
Yeah, matrix is 0.
Good. It's basically going to be same dimensions. All elements are 0. So let's say I have matrix A, which is A, B, C, D. And and I have the identity matrix is going to be the same dimension, so we can add them, right, as the original. So we're 2 by 2, but this time all the elements are 0. And what do we know about matrix A plus matrix I equals matrix A? What is an inverse in addition? So if I say like, oh, what's the inverse of 3? -3. Right? What's the rule to make it an additive inverse? When you add the two together, what does your sum have to be? 0, right? An additive inverse is the opposite that gives us a sum of 0. So if I have A, the additive inverse to A is -A, and the sum must always equal 0. All right, let's talk about the additive inverse for matrices. We'll call like negative matrix A. So what we need to know is if I have matrix A and I add the inverse of matrix A to A, our sum will have to be 0. Well, what do you think it's going to be? It's going to be the same dimensions with the same elements, just all the elements have to be what? Not negative, the opposite sign. You got it. So an example would be, if I had matrix A as 1, 2, 3, 4, what would the inverse of matrix A be? You got it. And what do we know about A plus -A? Well, what did we just call that before? The additive inverse. All right, couple things we need to know about additive matrix addition. Matrix addition is commutative and associative. Who remembers those words? What do they mean? Aish? Yeah, it means commutative means you can add in any order. So what that means is, let's just use basic integers. If I have 5 plus 3, isn't 3 plus 5 the same as 5 plus 3? Right, it's the same idea. If I'm adding two matrices, if I'm adding A plus B, it's the same as matrix B plus matrix A. It does not matter which one comes first. That's what it means. What about associative? Dylan?
Is it like distributing when you could put parentheses around it?
Parentheses, yes, but not distributing. So what it means is you're grouping together different things. So if I had matrix A plus matrix B plus matrix C, if there's no parentheses, normally we can just go in any order we want, right? But the minute I put parentheses, now what does it mean? I have to add B plus C first. What it means when it says associative, even if you have parentheses, it doesn't change the value. You're still okay. If I add A plus B plus C, if I add A plus B first, then B plus C, it's okay. If I add B plus C and then add that sum to A, it's still okay. So we can do different groupings and your sums will still be the same. That's what that means. All right, so matrix addition is so nice and easy. Matrix multiplication is not. So let's talk about that. right, so starting off simple, if you multiply a scalar, what a scalar means is just any real number with a matrix. All you're going to do is just distribute in that real number to every element of the matrix. I'll write that down for you. The product of a scalar, which is just any real number, and a matrix, just distribute in the scalar. So if I tell you find KA if K is equal to -3 and A is equal to first row -1, 2, -3, second row 13, -5, 4. So all you're going to do is you're going to take your scalar, you're going to take your matrix, and you're going to distribute in the scalar to every single element in your matrix. So we're going to end up with -3, 6, 9 as our first row. Second row, -39, +15, -12. I'm sorry? Oh, you're right. +3 and -6. Thank you. There we go. All right, so that was easy peasy. Now let's talk about the rule for multiplying two matrices together. Okay, so let's write this down. You can multiply two matrices if the number of columns in the first is equal to the number of rows in the second. So write this down and I'll show you what I mean. Rach, you writing a novel?
No, I was writing something in the past one.
Oh, okay. Good. Okay. So I'm going to start off simple. Let's say my directions are to multiply. And I have matrix A, which has the elements in the first row 1, 2, elements in the second row 3, 4. Then I have matrix B, which I have my first row elements are 5 and 6, second row 7 and 8. And then I want you to find AB. So before we multiply, what we want to do is we want to identify the dimensions of each matrix. So matrix A, so remember it's always row by column, right? row by column. That's how we identify the dimensions of a matrix. So how many rows? 2. How many columns? 2. What about the second one? 2 by 2. All right, this makes it pretty simple, but generally speaking, what we want to do is we want to make sure that the number of columns in the second one, that's this number. So basically the second number in the dimension, so the number of columns in the second one has to match the number of rows. Sorry, the number of columns in the first one has to match the number of columns. The number of columns in the first one has to match the number of rows. There we go, finally got it, in the second one. So basically, when you write out your dimensions, the second dimension has to match the first dimension in the second matrix. So these two spots have to be represented by the same numbers. The first two spots do not need to be the same, just the second and the first. All right, so then, since these two numbers match up, the remaining dimensions from each matrix, so that's a 2 and a 2, tells us what your product matrix is going to be. So the product matrix will be a 2 by 2. So it's basically your first dimension in the first matrix paired with your second dimension in your second matrix. All right, how do we multiply now? It's not fun. All right, so what we're going to do is we take the first row to start off with, and we're going to multiply it by the first column in the second one. What do I mean? So our very first, well, you know what sometimes helps? We know our product matrix will be a 2 by 2. So sometimes what I do is I just put little dashes for the elements so I know I have to have a 2 by 2. So I'm not creating a bigger matrix or a smaller matrix. I'm creating exactly what I need. So now how do I fill all these elements? What we're going to do is first we're going to do the first row times the first column. What does that mean? I'm going to have 1 times 5. This is all as my first element, plus, so the first element paired with the first element, plus, and now you're going to take the second element paired with the second element of that column. So plus 2 times 7. And that will represent our first element in our product matrix. Okay, now what am I going to do? All right, now let's go down to the second row, and I'm going to multiply it again with the first column, and that's going to be our element right underneath that first element. So now I'm going to do the same thing. I'm going to do 3 times 5 plus, what do you think? 4 times 7. You got it. So now I'm going to do these 2 rows again, but guess what I'm going to do them with this time? The second column, and that's going to give us our second column. So now we're going to have, once again, I'm going to do 1 times 6 plus 2 times 8. And now move down to 3, 4. We're going to have 3 times 6 plus 4 times 8. And now we simplify the elements. 1 times 5 is 5. 2 times 7 is 14. 3 times 5 is 15. 4 times 7 is 28. Up here, 1 times 6 is 6. 2 times 8 is 16. Underneath, 3 times 6 is 18. 4 times 8 is 32. And then we add. So 5 plus 14 is 19. 6 plus 16 is 22. 15 plus 28 is 43. 18 plus 32 is 50. And this is our product matrix. David, you may. All right, let's see one where it's not the same dimensions. Ryan? You're going to ask when it's not the same dimension? Yep, let's see one where it's not the same dimensions. Are we ready? Anybody still copying? All right. So now let's say I tell you that matrix A is first row -1, 2, -6. Second row 3, -1, 4. Our second matrix is first row -6, 4. Second row -2, 3. Third row 1, -4. All right, let's identify the dimensions. So remember, dimensions are number of rows by number of columns. How many rows does the first matrix have? 2 rows. How many columns does it have? 3. All right, the second matrix B, how many rows does it have? 3. How many columns does it have? 2. All right, what do I need to make sure is the same? The number of columns in the first one has to be the same as the number of rows in the second one. So now our product matrix will be the remaining dimensions put together. So my product matrix will be a 2 by 2. Are we ready? So I don't know, it helps. You don't have to do this. Since I know it's going to be a 2 by 2, all I do is make those, even though this is going to need to be a lot bigger, to be honest. All right, we ready? How do we do this? All right, so I'm going to do my first row, multiply it with my first column. All right, so we're going to have, you guys okay if I don't write out the multiplication, if I just multiply it? So we're going to do -1 times -6, which is 6, you got it, plus, now we're going to do 2 times -2, which is -4, plus, now we're going to do -6 times 1, which is -6. All right, now I'm going to first column, the element right underneath of the first element. So I'm still working in the first column. So now what do? I'm going to go down to 3, -4, 1. And what am I going to multiply this whole row with? Again, the first column. All this is just filling in my first column. So now we're going to do first element with first element, second element with second element, third element with third element, rows and columns. So 3 times -6 is -18. -1 times -2 is 2. 4 times 1 is 4. Add those. All right, so now what do we need to do? I filled in my first column. What do I need to fill in now? The second column. How am I going to do that? Same 2 rows, but now I'm going to multiply it by the second column in the second matrix. So now we're going to have -1 times 4 is -4. 2 times 3 is 6. -6 times -4 is +24. All right, then go down. 3 times 4 is 12. Negative 1 times 3 is negative 3. 4 times negative 4 is negative 16. And now you just simplify. So negative 10 plus 6 is negative 4. Negative 18 plus 6 is negative 12. 20 plus 6 is 26. And then 12 minus 19, right? 12 minus 19 is negative 7. And that is our product matrix. Was anybody still copying this top one? Okay, let's look at number 3. First thing before we multiply, what must we check? What must we check before we start multiplying? Same column and rows. So do we agree this is a 2 by 2? What is this one? This one is a 3 by 2. Are these the same? No, so we write can't be multiplied. Do you guys want to try one on your own? You should. Okay, have fun.
This one we're doing by ourselves?
Yep, this is the one you're doing by yourself.
I think I have the answer.
That's good. David? So what you have, it's not, you have a 3 by 2, right? And then here you have a 2 by 3. So you shouldn't get a 3, I'm sorry, you will get a 3 by 3. So then what you want to do you want me to show you? Okay. So David, you see this? So this gets multiplied with this, this, and this. Do you see what I'm doing?
Yeah.
Okay. Do we need help? Do you want me to do just one at least, and then you guys could do the rest?
No, we can do rest.
Ryan?
So, like, in regular multiplication of like integers, you can like swap the numbers around, right? But you can't do that for matrices.
So we're getting there. We're going to talk about that, but very good conclusion, Ryan. Matt? That's what Ryan just said. Absolutely, they are not commutative. Very, very good. Okay, guys, so what should we have gotten here? What we want to do is -1 times 3 is -3. -5 times -7 is a positive 35. Move down to your next element. 6 times 3 is 18. -3 times -7 is a positive 21. Move down to your third element in your first row. -4 times 3 is -12. 7 times -7 is a -49. So now you're going to do these 3 rows now all with the second column, and that's going to fill in your second column. Do we get it? Yes? Should I give you a couple minutes now to finish it up? Okay.
And then it doesn't come out English.
Who has an answer for me? Dylan?
32. So I'll go down by row, okay?
You mean column? You're going to name the columns? Okay.
32 and 39, -61, and then -29, -24, and 46, and then 30 and 51, and -69.
You got it. No. It should, oh wait, should it be a -30?
No, it should be
Positive? Okay. No, we're not done. Anybody want to see us do this? We're done with this problem. Anybody want to see us do this? No, we're okay?
I'm just confused about how you got the 30.
Should it be -30? I don't know. All right, let's see. So what we're doing is, which one is this? This is the third. You mean this one right here? Okay, let's do it. So then we're going to do -1 times 5 is -5. And then we have -5 times -35 is a positive 30, sorry, -5 times -7 is a positive 35. So then you have -5 plus a positive 35 is a positive 30. We're good? Anybody else want to see any of these elements? Okay. No. So, a couple of people brought this up. You came to it on your own. Multiplication, matrix multiplication. unitive. So what does that mean? A times B does not equal B times A. You cannot switch the order that you multiply. Why? That last problem was a perfect example. If I had, or was it a perfect example? I'm not sure. What did we have? We had a 2 by 3 and a 3 by 2. Yes. So if I have a 2 by 3 times a 3 by 2, what would end up happening? Oops, sorry. If I had a 2 by 3 times a 3 by 2, if I were to switch it, I would have a 3 by 2 times a 2 by, oh, this was supposed to be a 2 by, I should have switched it, hold on. This is a 2 by 3, and then I'm going to make this a 3 by 3. There we go. Does that work? Yes. Okay. So if I have a 2 by 3 and then I have switch it 3 by 3 times a 2 by 3, these are not the same, right? So it doesn't work. So you cannot switch how you multiply things. You cannot switch how you multiply things. It is associative though. What does that mean? If I have A times B times C, you can change not the positioning, but the grouping. So I can multiply B times C first, or I can multiply A times B first. It's all going to work out. I did have one more thing to show you, but I don't think I have enough time to show you, but you do have enough to do most of your homework at this point. I'll take off the problems that you're not able to do, and it'll be like, there's like maybe 5 more minutes of this lesson tomorrow.